Welcome to a new e-learning paradigm, AplusMap.ai.
Today we are tackling a concept that's, it's absolutely foundational for understanding how economies really work.
Mm.
And honestly, it pops up all the time on the AP economics exam. We're diving deep into factor markets. And our mission today, it isn't just about, listing definitions. We really want to unpack how these essential resources, think labor, land, capital, how they get bought and sold, and maybe most importantly, how their prices are set. We're aiming for those aha moments, those insights that'll really stick with you for test day.
That's absolutely the goal. Because understanding factor markets isn't just theory, right? It's seeing the actual mechanics of the economy. Think about it, everything from how a local business decides whether to hire someone new, to why wages might be different in different towns, or even what happens when, one big company basically dominates the job market somewhere. We'll be breaking down how businesses figure out, okay, how many workers do we actually need? Why do wages go up or down? And what does that mean for everyone involved?
Okay, so let's start right at the beginning then, the absolute basics. What exactly is a factor market? How does it fit into, the bigger picture?
Yeah, great place to start. So a factor market, basically it's the marketplace where resources get bought and sold. These resources are the essential ingredients needed for production. You might hear them called factors of production. It's where businesses go shopping for what they need to make stuff. And there are four main factors. First, you've got land. What does land earn? Rental income. Then there's labor. That earns wage income. And honestly, labor and wages, that's going to be a huge focus for us today. Super common on the AP exam. Next up is capital. Think tools, machines, buildings. That earns interest income. And finally, entrepreneurship. That spark, the risk-taking. That earns profit. And just a quick point here, because it can be confusing, remember, in the factor market, businesses are the ones demanding these resources. Households, like you and me, we're the ones supplying them.
Okay, so it's kind of the reverse of when we go shopping for, say, a coffee there. We're the demanders. Here, for labor, we're the suppliers.
Exactly. Businesses demand labor, households supply it.
Got it. Now, you mentioned this earlier, but there's a really key concept here called derived demand.
Yeah.
What's driving the demand for these factors? Is it just businesses deciding they need more people? Or is something else going on?
Ah, yes, derived demand. This is the crucial link. It means the demand for a resource, say labor, doesn't just exist in a vacuum. It directly depends on the demand for the final product that labor helps create.
Okay, so it's derived from something else.
Precisely. Think about pizza makers. If suddenly everyone wants more pizza,
Then pizza places need more people to make the pizza.
exactly. The demand for pizza makers goes up. But if, say, car sales take a nosedive,
Then there's less demand for auto workers.
right, fewer cars being sold means less need for the people who build them. So this concept, derived demand, it's super important because it connects the product market, where we buy pizza and cars, directly back to the factor market, where the pizza makers and auto workers are hired.
That connection makes a lot of sense. The demand for workers really flows from what we, as consumers, want to buy. So, okay, businesses know they need workers because people want their products, but how do they figure out the exact number? Like, how many people should they actually hire? I think this brings us to those core tools: marginal revenue product, MRP, and marginal factor cost, MFC.
Absolutely. Now we're getting into the decision-making calculus for the firm. Let's break these down. First, marginal revenue product, or MRP. This is the extra revenue a firm gets from hiring one more worker, just one additional worker. The formula is MRP equals marginal revenue, MR, times the marginal product, MP, of that worker. So how much extra stuff does the worker make and how much revenue does that extra stuff bring in? And here's a tip for the exam. Under perfect competition, which is a common assumption, marginal revenue equals the price, P. So you can often think of MRP as P times MP. Definitely keep that formula handy.
Okay. MRP is MR times MP, or price times MP in perfect competition. That's the benefit side of the extra revenue. What of the cost?
Right. The cost side is marginal factor cost, or MFC. You might also see it called marginal resource cost, MRC. Same thing. This is simply the additional cost of hiring one more worker. Now, in a perfectly competitive labor market, we'll get more into that structure soon, the MFC is just equal to the market wage. Whatever the going wage is, that's the cost of hiring one more person. The general formula, though, is MFC equals the change in total factor cost divided by the change in resource quantity. Basically, how much did my total cost go up when I hired that one extra worker?
Got it. So MRP is the extra revenue, MFC is the extra cost. How do firms use these two?
Ah, the golden rule. The profit maximizing rule for hiring labor is super simple. conceptually. Hire workers up to the point where MRP equals MFC.
Hire until MRP equals MFC.
Exactly. Think about it logically. If hiring another worker brings in more revenue, MRP, than it costs to hire them, MFC, should you do it?
Yeah, definitely. You're making a profit on that worker.
Right. So you keep hiring, but what if you're considering hiring, say, your sixth worker, and their MRP is $10, but the MFC, the cost to hire them, is $20?
Uh-oh. Then you'd lose $10 on that hire. No way.
Precisely. You wouldn't hire that sixth worker. So if the fifth worker's MRP was, say, $22 and the MFC was $20, you'd hire them. But the sixth worker crosses that line. So the fifth worker is your profit-maximizing amount of labor.
That makes perfect sense. It's just a cost-benefit analysis for each potential hire. Classic economics. You'll definitely see this logic on the exam. Okay, we've got the rule. Now let's visualize this stuff. Graphs are always huge in AP Econ. What do these labor market graphs look like?
Yes, the graphs really help tie it together. So typically you'll see the wage rate on the vertical y-axis and the quantity of labor on the horizontal x-axis. And here's that point again because it trips students up. In the labor market, who are the demanders?
Businesses. They demand labor.
Right. Businesses demand labor. And who supplies it?
That's us, households. We supply our labor.
Perfect. Got to keep that straight. It's the opposite of the product market. And a little tip for the demand curve in the labor market. You can think of the market demand for labor, DL, as the sum of all the individual firms' MRPs. It's just adding up how valuable each potential worker is across all the firms wanting that type of labor.
Okay, summing up the MRPs gives us the market demand. Now, just like with goods and services, these factor markets don't stay still, right? Things shift the curves. What causes the demand or supply of labor to change? Especially demand shifters, you said those are important.
Exactly. Let's focus on the key demand shifters for labor, because these are very likely to show up on your exam. Number one, change in demand for the final product. This goes right back to derived demand.
Right, the pizza example, more demand for pizza.
More demand for pizza makers, demand for labor shifts right, car sales drop, demand for auto workers, shifts left. Simple as that.
Okay, what else shifts demand?
Number two, change in productivity of the resource. If workers become more productive, maybe they get better tools, new technology, or more training, their marginal product, MP, goes up.
And if MP goes up, MRP goes up too, right? Because MRP equals price times marginal product.
Exactly. Higher MP means higher MRP. That worker is now more valuable to the firm, so the firm's demand for that type of labor increases. The demand curve shifts right. Think about like a construction worker getting a new power tool that lets them work twice as fast. That worker's way more valuable now.
Makes sense. Productivity is key. What's the third one?
Number three, change in price of substitute or complementary resources. So substitutes first. If a substitute for human labor gets way cheaper.
Firms might buy the machine instead of hiring a person. Demand for labor goes down.
Right, shifts left. Now, complements. These are resources used together. Think chefs and waiters. If a restaurant hires more chefs, what happens to their need for waiters?
They'll probably need more waiters too to serve the extra food.
Exactly. They're complements in production.
Right.
So an increase in demand for chefs can lead to an increase in demand for waiters. Demand for waiters shifts right.
Got it. Product demand, productivity, and prices of other resources. Those are the big demand shifters.
Those are the main ones to focus on for the exam. There are supply shifters, too, like changes in population or people's preferences for work versus leisure or opportunities in other job markets. But the source material suggests these are less likely to be heavily tested, so definitely nail those demand shifters.
Okay, demand shifters down. Now, let's zoom in on a specific market structure, the perfectly competitive labor market. This is kind of the baseline model, right? What are its defining features?
Yeah, it's the standard starting point. Key features you need to know. First, there are many firms hiring and many workers supplying labor. Crucially, firms are wage takers. They have no power to influence the market wage. They just accept whatever it is. Second, we assume workers are identical in skill and ability, makes the model simpler. Third, the hiring rule is still MRP equals MFC. That holds true. Fourth, in this specific market, because firms are wage takers, the market wage equals the MFC. The cost of one more worker is just the market wage. And fifth, the firm's MRP curve slopes downward because of diminishing marginal returns. As you add more workers, eventually each additional worker adds less to output than the previous one.
Okay, wage takers, identical workers, MRP MSC, wage MFC, and diminishing returns driving MRP down. Now, the graphs for this, you mentioned a market graph and a firm graph.
Right. So on the left, you have the overall labor market.
Yeah.
You've got your upward sloping supply curve for labor. Higher wages attract more workers. And your downward sloping demand curve for labor. That's the sum of all firms' MRPs, where
Right.
they cross. That gives you the equilibrium market wage. Let's call it WE.
What about the individual firm?
Now look at the right graph, the individual firm. Since this firm is a wage taker, it faces a particularly horizontal supply curve for itself. This horizontal line represents its marginal factor cost, MFC, and it's set precisely at that market wage, WE.
So it can hire as many workers as it wants at that market wage.
Exactly. It perceives the supply of labor to it as perfectly elastic at the market wage. Then you have the firm's own downward sloping MRP curve. Where does the firm hire?
Where MRP hits MFC.
Precisely. The intersection of the firm's MRP curve and that horizontal MFC line determines the quantity of labor the firm will hire. Let's call it Q. And a really, really important point here, maybe highlight this for your notes. That horizontal line for the firm is its supply of labor curve, or MFC curve. It is not a demand curve. It represents the price the firm pays for labor.
Got it. Horizontal MFC wage. Supply to the firm. Downward MRP is the firm's demand for labor. They hire where the two meet. Okay, that setup is clear. Now let's get dynamic. These are the scenarios that really test your understanding, the things to try for the exam. What happens when things change? Let's take case 1. Market demand for the product increases.
Right, this is a classic. So case 1, market demand for the product increases. First, look at the market graph. The demand for the final product goes up. Because of derived demand, the demand for labor also goes up. So the market demand curve for labor shifts to the right.
And what does that do to the market wage?
It pushes it up. The new equilibrium will be at a higher wage and a higher overall quantity of labor hired in the market.
Okay, market wage rises. Now what about our little individual firm over on the right graph?
This is where it gets interesting and a bit counterintuitive, maybe. The market wage went up, right? So the firm's horizontal MFC line shifts up to that new higher market wage.
Okay, their cost of hiring just increased.
Exactly. Now, the firm still follows the rule MRP equals MFC, but its MRP curve hasn't changed. So where does the new higher MFC line intersect the old MRP curve?
Further to the left, at a lower quantity of labor.
Precisely. The firm moves up and to the left along its MRP curve. It ends up hiring fewer workers than it did before the wage increase, even though it's paying them more.
Whoa. Okay, hold on. The market hires more workers overall, but the individual firm hires fewer workers. That seems weird.
It does seem weird, but it makes sense if you think about costs. For the individual firm, the cost of its input, labor, just went up. Like if the price of coffee beans goes up for a single cafe, that cafe might brew less coffee, right?
Right.
Even if people overall are drinking more coffee, the higher cost forces the individual firm to scale back its hiring.
Okay, that analogy helps.
Yeah.
Higher input costs for the firm leads to less hiring by that firm.
Right. So keynotes for this one, because it's tested often. First, market wage increases. Second, the firm's MFC, its wage cost, increases. Third, the quantity of labor hired by the firm decreases, leading to that conclusion. More hiring in the market overall, but less hiring at the individual firm level. Definitely practice that one.
Will do. Okay, case 2. What if the market stays the same, but something changes inside just one firm? Like, say, the workers at one company get way more productive.
Good scenario. Case 2, change inside the firm, market stays the same. So on the market graph, nothing changes. Supply and demand for labor in the overall market are the same, so the market wage stays put.
Okay, wage is constant. What about the firm where productivity increased?
Right. So inside this one specific firm, maybe they got new technology or better training, so the marginal product, their labor, goes up.
And higher MP means?
Higher MRP. The firm's MRP curve shifts to the right. Each worker is now generating more revenue for this specific firm.
Okay, MRP shifts right. But the wage, MFC, stayed the same because the market didn't change.
Exactly. So now where does the new shifted MRP curve intersect the old unchanged horizontal MFC line?
Further to the right, at a higher quantity of labor.
You got it. The firm will now hire more workers at the same market wage because each worker is now more valuable to them.
That makes sense. They become more productive, so the firm wants more of them at the current price.
Right. So keynotes here. First, only this one firm's MRP shifts right. Second, the firm's MRP increases. Third, the market wage stays the same, but the number of laborers hired by this firm increases. Classic example of how a productivity change boosts labor demand for that specific firm.
These dynamic cases are crucial. Definitely worth sketching out. Okay, let's shift to a real-world policy application. Minimum wage, huge topic, always debated. What's the economic take? What happens when you set a wage floor?
Right, minimum wage. So, the definition. It's a price floor in the labor market, the lowest legal wage allowed. For it to actually do anything, to have an effect, it needs to be binding. And what does binding mean here?
It has to be set above the equilibrium wage, right? Otherwise, the market wage is already higher, and the floor doesn't matter.
Exactly. A minimum wage set below equilibrium has no effect. It must be above the market clearing wage to be binding. Definitely remember binding price floor for the exam.
Okay, so we have a binding minimum wage above equilibrium. What are the effects?
Well, first, for the workers who keep their jobs, they get a higher wage. That's the intended benefit. But there's a downside. Unemployment, or put another way, a surplus of labor.
How does that happen?
At the higher minimum wage, two things happen simultaneously. First, more people are willing to work at that higher wage, so the quantity of labor supplied increases.
Okay, more people want jobs.
But second, firms facing this higher mandatory wage cost, a higher MFC, want to hire fewer workers. The quantity of labor demanded decreases.
So more people want jobs, but firms offer fewer jobs. That creates a gap.
Precisely. That gap between the quantity supplied and the quantity demanded at the minimum wage is unemployment, a surplus of labor. It tends to hit low-skill workers hardest because their MRP might be below the new minimum wage, making them too costly for firms to hire.
And on the graph, how does that look?
You draw a horizontal line representing the minimum wage above the equilibrium intersection. Where that line hits the demand curve shows the quantity demanded, QD. Where it hits the supply curve shows the quantity supplied, Qs. Since the line is above equilibrium, Qs will be greater than Q'd, that horizontal distance between Q'd and Qs. That's the amount of unemployment caused by the minimum wage.
Clear visual. So summarizing the keynotes for minimum wage.
Okay. 1, minimum wage is just price floor. 2, must be above equilibrium to be binding. 3, causes unemployment, a surplus of labor, Qs QD. 4, why do firms hire less? Because for some workers, their MRP is now less than the new MFC, the minimum wage. 5, firms always hire where MRP, MFC, or up to that point.
Got it. Price floor, binding above equilibrium, causes unemployment. That's a really important application. Now, we've mostly talked about perfect competition on the hiring side, but what if there isn't much competition? What if there's basically only one major employer in town? That brings us to monopsony. This sounds like the flip side of monopoly.
It is, in a way. Monopoly is one seller. Monopsony is one buyer. So characteristics of monopsony. One firm is the primary or even sole buyer of a particular type of labor. This gives the firm significant market power, allowing it to influence the wage, typically setting it below what it would be in a competitive market. Now, the firm still hires using the MRP equals MFC rule, but the way MFC works is different, and crucially, the wage they pay is less than the worker's MRP.
Okay, one buyer, power to set wages, pays less than MRP. How does this compare starkly to perfect competition?
Let's do a quick rundown. Perfect competition, PC. Many firms hiring, firms are wage takers, market sets the wage, usually results in a higher wage, more jobs, and it's considered allocatively efficient the right amount of labor gets employed. Monopsony. One major employer. Think classic company town, though it can be more subtle today. The firm is a wage setter. It typically pays a lower wage than the worker's MRP. It hires fewer workers than a competitive market would. This leads to underemployment and is considered inefficient because valuable labor resources aren't fully utilized.
So the quick takeaway, PC, higher wage, more jobs, efficient. Monopsony is lower wage, fewer jobs, inefficient.
Yeah.
Big difference.
Huge difference.
What does the monopsony graph look like? You said the MSC is different.
Right. This is key. In monopsony, the firm faces the entire upward-sloping market supply curve of labor. To hire one more worker, they have to offer a higher wage, not just to that new worker, but to all their existing workers, too.
So the cost of hiring one more worker isn't just that worker's wage. It includes raising everyone else's wage, too.
Exactly. That makes the marginal factor cost, MFC, or marginal resource cost, MRC, increase faster than the wage rate itself.
Yeah.
So the MRC curve lies above the labor supply curve and is steeper.
Okay, MRC curve is above the supply curve. Where does the firm hire?
Still where MRC equals MRP. Find that intersection point, drop down to find the quantity of labor the monopsony hires.
Yeah. What wage do they pay? Do they pay the wage associated with the MRC MRP point?
No. And this is the crucial part. To find the wage, you take that quantity QM and go down to the labor supply curve. That tells you the wage maybe the firm needs to offer to attract exactly QM workers.
So they hire based on MRC MRP, but pay based on the lower supply curve.
Precisely. Willem will be lower than the MRP at quantity QM and also lower than the wage, WC, that would exist in a competitive market. Result: fewer workers hired, QM/QC, and lower wages, Willem WC-Me.
And that inefficiency you mentioned, can we see that on the graph too?
Yes. If you compare the Monopsony outcome, SWAM, to the perfectly competitive outcome, QC, WNEC, where supply equals MRP demand, you'll see a triangle between the supply curve and the MRP curve for the quantities between Q and QC. That triangle represents deadweight loss, DWL.
Deadweight loss. That's lost potential value, right?
Exactly. It's the lost total surplus value that could have been created if the efficient quantity of labor, QC, had been hired, but wasn't because of the monopsonist's power to depress wages and employment.
Wow. So keynotes from Monopsony. MRC is above supply. Higher, where MRC MRP pay the wage off the supply curve, results in lower wages, William WC, and fewer jobs, Q and QC, the competition, and it creates deadweight loss, meaning it's inefficient.
You've got it. It underpays and underhires, which, raises questions about policy interventions like minimum wages or support for unions in such markets, as they could potentially counteract the monopsony power and push towards a more efficient outcome.
That's a really important link between the theory and potential policy responses. Okay, one last concept, briefly. The least cost rule. This is about firms choosing between different resources, right? Like labor versus machines.
Exactly. It's about cost minimization when using multiple inputs. Let's say a firm uses both labor L and capital K. How does it decide the optimal mix to produce a certain amount of output at the lowest possible cost? The core idea, without getting deep into the formula, which might be less emphasized, is that the firm should adjust its mix of inputs until the marginal product per dollar spent is equal for all resources.
So the extra output you get from the last dollar spent on labor should equal the extra output you get from the last dollar spent on capital.
That's the essence of it. You keep shifting spending towards the input that gives you more bang for your buck until the return per dollar is equalized across all inputs you use. It's about optimizing the combination.
Finding that optimal mix to minimize cost. Got it.
This is the last chapter. Check the answers to the practice problems you solved in the video. Got it, everyone. Hope you followed along with today's lecture. Now, let's break down those quiz answers and make sure everything we covered really sticks. You can grab the complete mind map Musica. It's a killer snapshot of today's lesson, plus a super detailed AP Economics textbook at www.aplusmap.ai. Ready? Let's get into those quiz answers.
Wow, okay. We have covered a ton of ground on factor markets. So pulling this all together, what's the big picture takeaway for an AP Economics student listening to this?
We really did dive deep, from the basics of what factor markets are and derived demand, through the core decision rule of MRP equals MFC, into the specifics of perfectly competitive markets and how they react to changes. Then we tackled the real-world issue of minimum wage and its effects, and explored the completely different dynamics of a monopsony market. And finally, touched on optimizing resource use with the least cost rule. I think the absolute key takeaway is this. Firms don't hire randomly. They make calculated marginal decisions based on comparing the extra revenue a resource brings in, MRP, with the extra cost of hiring it, MFC. And crucially, the structure of the market, whether it's perfectly competitive or a monopsony or something else, has a huge impact on the resulting wages and how many people get hired. Efficiency really depends on competition.
That makes perfect sense. It's all about those marginal decisions and the market context.
And maybe a final thought to leave you with. If knowledge is power, and you now have a much better handle on how labor markets work, how wages are set, how employment levels are determined, think about what that means. How might this understanding influence your own future career choices? Or how you interpret news about wage debates or unemployment figures, or policies aimed at the job market? This isn't just abstract stuff for an exam. It's deeply relevant to how our economy and society function. It's knowledge for life, really.
That's a great point. Understanding the mechanics gives you a powerful lens to view the world. Keep those economic thinking caps firmly on.
We hope you're excited for what's next. For more learning materials, please visit aplusmap.ai.